Yes, Samya, please mute yourself. Yes, please turn on your camera. So I'll be starting from the basic. Okay. Here also, here and there, you will find that terminology, that congruency is there. Okay, two triangles are congruent with each other, another two triangles are similar with each other. So basically here we need to discuss what does that mean. Similarity of two triangles means what? Okay, similar triangle means what? Just a second. Similar figure means what? Okay, similar figure, similar triangle. Basically we'll be covering over here, but before that we will see what is congruent triangle or congruent figure. Okay, so as okay, most of you from here are from my previous batch. Okay, you understand congruency means what? If I am taking one of the shape, let's say I am drawing one rectangle and I am drawing another rectangle. The first rectangle is PQRS and the second rectangle is ABCD. Okay, if we are saying these two rectangles are congruent with each other, if I am saying that rectangle ABCD and rectangle PQRS are congruent with each other, that means each and every sides, that means AB side. Here length of this rectangle must be equal to length of that rectangle, right? That's the meaning of congruency, right? If I am saying that not triangle, rectangle, if I am saying that rectangle PQRS is congruent with rectangle ABCD, that means AB is equals to PQ. Okay, BC is equals to QR, CD is equals to RS, and AD is equals to PS, right? Right? These two figures are exactly same in measurement. Both will cover each other completely, right?
Yes.
Okay. Apart from that, what else will be same? So each and every interior angle will also be same. Okay, angle P over there will be equals to angle A. And since we are talking about rectangle, of course, okay, each and every interior angle in both the rectangle, even if these two are congruent or not congruent, okay, each and every interior angle will always be 90 degree if just I am saying rectangle. So in this case, yes, each and every interior angles are also same. Okay, so congruency means sides will be same and angles will also be same. Okay, so PA, okay, this way we can write Q and B, this way we can write R and C, and angle S and angle D, these all the corresponding angles will also be same. In case of rectangle, automatically it is coming same, but even if I will take another shape, a quadrilateral PQRS and a quadrilateral ABC, if I will say, okay, rather than saying rectangle, if I will say there is a quadrilateral ABCD and there is a quadrilateral PQRS and these two are congruent with each other, that means this is the meaning of congruency. We understand congruency really well, and this is the meaning of congruency, right? You have also learned few
Yes.
criterias which were helping to prove whether the triangles are congruent or not. So when we started discussing about triangle, there were few criterias, the bare minimum criteria, which were helping us to check whether triangles are congruent or not. And the criteria for congruency of triangles, you were having side criteria. Okay, side criteria, angle criteria, angle side criteria, RHS criteria, right angle, hypotenuse, and one of the side. Okay, this means side. Okay, this was the bare minimum criteria, that if you don't know all the data, if you are not able to match all the side and all the angle, then just at least match this much. Okay, who joined? Inan, we have started triangles over here. Okay, our team will be arranging extra classes for you for the chapters which we have not discussed. Okay, I have not discussed with you first chapter and the other chapters as well. For now, I have started triangle. Let's finish it and then I'll be taking AP. Okay,
Okay, ma'am.
is it okay, Inan?
Yes, sir. Yes, ma'am.
Okay. So just now I started the discussion that at first you have learned in the previous class congruency of triangles. Okay, and here we are having similarity of triangles. So just now we are just okay revisiting the same concept, that congruency is what. Okay, so I said that we are having two figures, okay, two rectangles which are congruent with each other. You can see the figure over here. Okay, if we are saying two rectangles are congruent with each other, that means the first rectangle is covering the second rectangle completely. Both are exactly same, right?
Yes, ma'am.
Okay. Yes, Inan, you understand congruency means what?
Yes, ma'am. It means like
Same figure,
same
exactly.
angle and same size, right?
Yeah, same side, same angle. You can see I have just written that PQRS is same as ABCD. Congruent sign I have given. That means ABPQ, BCQR, CDRS, and the other side same. Angle P, angle A. Okay, angle B is equals to angle Q and B are same, R and C are same, S and D are same. Okay, so that's what we were discussing. And criteria for congruency, these were the criterias for checking the congruency of two triangle. Okay, so five criterias you were having over there. Here also you will see criterias for checking similarity of two figure. Now similarity means what? We will be starting. Let's complete this one. So side angle side criteria you were having, angle side angle criteria you all have learned, angle side criteria, and right angle hypotenuse and one of the side, right angle hypotenuse and one of the side. Okay, so these were the congruency criteria, that if you don't know everything about two triangle, if you don't know what are the measurement of each and every side and what are the measurement of each and every angle, then at least we were matching any of the criteria from here. At least bare minimum, if we will be able to match side, then confidently we can say yes, this two triangle will be congruent. Or maybe bare minimum, if we are able to match side angle side, just side angle side, okay, then we were declaring that yes, the triangles are congruent. So mathematicians has given these criteria, that bare minimum at least you try matching this much, then confidently you can say that yes, the remaining all will be same, all the remaining sides, all the remaining corresponding angle will be equal. Okay, so we were doing questions from here. Today we are going to start the discussion from similarity of two figures. Now, what does that mean, similarity of two figure? Let's see. Suppose we are having a quadrilateral. A quadrilateral we are having, let's say ABCD, okay, whose measurement is this way. AB is, let's say, 2 centimeter, BC is 5 centimeter, okay, CD is just 4 centimeter, and AD is, let's say, 3 centimeter. Okay, this is how we are having the measurement of this quadrilateral. Now we are having one more quadrilateral. I am drawing it. This is quadrilateral PQRS. Okay, here PQ is 8 centimeter, QR is 20 centimeter. Okay, this one is again 16 centimeter, and this one is 12 centimeter. Okay, yeah, then we will see there is a relation between the sides. Okay, these two figures are similar with each other. Now similarity means what? How we are saying these two are similar? So listen to me carefully. Similar doesn't mean these two are exactly same in shape and size. Yes, shapes are same. Okay, these two are, this is also quadrilateral and this is also quadrilateral. So the shape is same. Okay, but the size is not same. So when you are comparing two figure, the shape has to be same. You cannot compare a circle with a triangle. Okay, you cannot compare a quadrilateral with a triangle. So the shape has to be same. Now size, if you will notice carefully, you will find that here AB is 2 centimeter and here PQ is 2 into 4, that is 8 centimeter. If you will see carefully, you will find that here BC is 5 centimeter and here QR is 5 into 4, that is 20 centimeter. Here CD is 4 centimeter and here your SR or RS is 4 into 4, that is 16 centimeter. And here AD is 3 centimeter, so here PS is 3 into 4, that is 12 centimeter. That means we are not randomly increasing. Okay, one of the figure we are having now with the help of notepad. Okay, I'm just stretching the figure, but randomly I'm not trying to stretch the picture. Okay, I will be expanding it or compressing it in a certain ratio. In a certain ratio, I will maintain all the ratio same. What does that mean? That means if you will check AB is to PQ, you will be getting 2 by 8. This is nothing but 1 by 4, and the same ratio I have maintained for the other sides as well. See carefully. Okay, if you will notice BC is to QR, you will find it is 5, actually it is 5, and actually it is 20, and that is again 1 by 4. Okay, so in a certain proportion, in a certain ratio, we are expanding the shape or we are compressing the shape. This type of shape are called similar figure. Randomly, if you are expanding or compressing, we cannot say the figures are similar. You can check the other ratios as well. You can check CD by RS, and you will find that CD is 4 and RS actually is 16. I'm rubbing this multiplication part. Okay, this can create confusion. See the actual data. So you are getting 1 is to 4. If you will check the other side, that is PS is to AD, you will find that the ratios are 3 is to 12, that is again 1 is to 4. Can you see all the ratios are same? Can you see it?
Yes, ma'am.
This happens with similar figure. Okay, that means a teeny tiny triangle and a huge bigger triangle can be similar with each other if the ratio is maintained in this way. That means, okay, sides are proportion. sides are in proportion with each other. Now, when I'm saying in proportion, that means in maintaining the same ratio. In proportion means maintaining the same ratio. Sides are in proportion with each other. That means sides are maintaining same ratio with each other. Okay. So this is the first condition which needs to be fulfilled. Okay. The way you understand congruency means all the sides are same and corresponding angles are also same for any figure. Similarly, you have to understand similarity means all sides must be in proportion with each other. In proportion means maintaining same ratio with the corresponding side. Maintaining same ratio with the corresponding side. This is the first condition which needs to be fulfilled. Making sense? And the
Yes,
second
ma'am.
is each and every angle, corresponding angles has to be same. These are the only two conditions which needs to be fulfilled, and once you will find that these two conditions are getting fulfilled, you will say that yeah, these two figures are similar with each other. And if you are thinking that no, how can the angle be equal with each other? So let me tell you, yes, the angle will be equal. Doesn't matter if your triangle is teeny tiny or a huge, or maybe if your quadrilateral is teeny tiny quadrilateral or huge. At the end, are you understanding that angle A, angle B, angle C, angle D all added together will make 360-degree? Are you
Yes,
getting?
ma'am.
Here also angle P, angle Q, angle R, angle S all added together will make 360-degree. So doesn't matter if you will make a huge quadrilateral, then the angle will also come out as a huge. No, no. The angle will not be huge if you are making a huge quadrilateral. At the end, all together will make 360-degree, even if you will make a this tiny tiny quadrilateral or a huge quadrilateral. Getting it? That's why we are saying that corresponding angle will be equal with each other. Is it making sense to all of you?
Yes, ma'am.
Okay, now here for similarity we'll be using a symbol. Okay, congruency symbol you already understand. And yeah, okay, in this chapter's name is triangle, so basically we'll be focusing on similarity of triangle. Okay, this is the symbol which says similar. Just recall, it is something like the congruency, but not exactly. This is congruent, okay, and this is similar. So in your exam, when any question will be given to you, be careful. The question will be can be from congruency, can be from similarity. You have to see the symbol carefully. Okay. Now let's, once you understood about what exactly is the meaning of similarity, let's take few cases. So suppose example number 1 says we are having a triangle ABC and we are having another triangle. Now you will often, okay, you will find me writing just creating this type of figure which are not exactly equal. Okay, so another triangle is PQR. Now these two triangles are similar with each other. I'm trying to just suppose I'm telling you these two triangles ABC is similar with PQR. Okay, let's have a feel that what does that mean. Now you understand that sides are in proportion with each other. That means once you will see this written part by yourself, you will write AB by PQ. Systematically you have to maintain the ratio. Are you getting me? That ratio will be equals to BC by QR. See, the I'm taking first two alphabet, that these two are making ratio. Okay, creating ratio with each other. The next two alphabet, that means BC with QR, this two creating ratio. Okay, this two has to be same if I'm saying these two triangles are similar. And the last one, that is this AC side over here will maintain PR. Okay, with PR it will maintain the same ratio. Is it making sense to all of you? How we were taking the sides in congruency, similarly we are taking sides over here also, but there we were taking it same. There we were saying that AB and PQ are same, but here we are saying AB by PQ. Are you getting it?
Yes,
Yes,
ma'am.
ma'am.
Okay, just give me a moment now. So this is the meaning of similarity. Okay, AB by PQ will maintain the same ratio as BQ by QR. Is equals to AC by PR. But this is not the only condition which needs to be fulfilled. If already you know these two triangles are similar with each other, then one more thing you will be getting over here, and it is same like the congruency, that corresponding angle will be same. That means angle A over here will be equals to angle P over there. Okay, angle B over here is equals to angle Q over there, and angle C over here will be equals to angle R over there. This condition will automatically it will follow once you know these two triangles are similar. Making sense?
Yes, ma'am.
First,
Yes, ma'am.
I'm just trying to explain you what is the meaning of similarity, just that. Okay, what is the meaning of similarity? Just you are trying to understand that meaning of similarity means we are just stretching the figure or compressing the figure, the way it happens in the suppose I will give a passport size photo to the like shopkeeper and will ask to make another, okay, another measurement that make it bigger or smaller, but the measurement which is already okay mentioned, that this size that size all are similar only. Okay, they do these things by maintaining a proper ratio. Okay, that's what we are discussing over here, that when we will compress the figure, when we will stretch the figure, while maintaining the same ratio, and angle, corresponding angle will be same. That is the meaning of similarity. Okay, we will end up creating a similar figure. Let's move and let's see about congruency. Two figures which are congruent with each other. Listen to me carefully. If two figures are congruent with each other, suppose you are having a triangle MNO, and a triangle RST. If these two, I am declaring, okay, if these two are congruent with each other, if I am saying that triangle MNO is congruent with triangle RST, then automatically this two figure will be similar with each other. Are you getting my point?
So,
Yes,
ma'am,
ma'am.
so we should just prove it's congruent.
If two congruent figures are always similar. Why? Because from here we have a understanding that MN and RS will be same. From here we have a understanding that NO and ST will be same. Or by CPCT, MO and RT will also be same. From here, we do have understanding that angle M, angle R will be same. From here, we have understanding that angle N and angle S will be same by CPCT. Angle O and angle T will be same. Now, if we will check that will it be similar or not by just checking the ratio. Okay, just by checking the ratio, if you will try checking, then you will find that the ratios are 1 is to 1. That means Mn by Rs, you are just finding the ratio just to check, and you are realizing, okay, these two are same, then the ratio is 1 is to 1. Okay, what about the other ratio? When you will try checking, you are just checking it. Okay, you are just checking it, that these two triangles can be called similar. So you Mn by Rs you are trying to find, but you realize these two are same. Okay, so if this is x, this is also x, that means the ratio is 1:1. Similarly, if you will just try checking, you are checking it. Okay, suppose I have not told you anything about similarity and I am telling you let's check it. So NO by ST we are checking. Suppose this is y, this is also y. That means 1:1. Suppose we are checking the ratio. Okay, MO by RT. That is Z by Z. That means 1:1. Can you see the ratios are equal? Whatever be the ratio, the ratios are equal.
Yes,
And
ma'am.
automatically the angles, okay, angle were already corresponding angle by CPCT, it was equal. So which is helping us to say that yeah, ratio is also equal and the angle is also equal, hence similar. Yes or no?
So like congruent triangles are also like similar.
Always similar, also similar, always. Yes, congruent figure are always similar with each other. This MCQ you will be getting here and there, that congruent figure are always similar. Why? Because once it is congruent, then the sides, there will be one of the side over here which will be exactly same as one of the side over here. And once we will try finding the ratio, automatically the ratio will, automatically it will come out same and the angles are same. So similarity means if the ratios are same and the angles are same, figure are similar. Okay, if the corresponding sides ratio and corresponding angles are equal, then the triangles are similar with each other. Wherever this condition will be fulfilled, we will say that figures are similar. So here this condition is getting fulfilled and always it will get fulfilled. Always, whenever two figures are congruent, those two figure will definitely those two figure will be similar. Is it making sense?
Yes, ma'am.
Yes, ma'am.
But reverse way doesn't work. Why? If I will say two figures are similar with each other, okay, suppose I am saying that a triangle is there that is PQR, I'm not drawing the triangle, is similar with a triangle that is ABC, then you cannot say this two will also be congruent. Why you cannot say? Because here by this condition, the given condition, you understand that PQ by AB, this ratio, whatever be the ratio, will be same as QR by BC. And this two will be same as PR by AC. Apart from that, angles will also be same. So angle P, see angle P in an, do you understand angle P over here and angle A over here will be equal? Do you understand in an that systematically we take the angles also? Yes or no? The way you were comparing the angle by CPCT in congruency, same way we are taking the angles over here also. Yes, Inan, are you getting it?
Yes, ma'am.
Okay, so this is the meaning of similarity. If the given part is this one, then this is the meaning. This is the meaning of similarity. Okay, the conclusion we have written by ourselves. From here, can you say that triangles are congruent also? Let me draw the triangle. Okay, one of the triangle is PQR, another triangle is ABC. Okay, here I have not given the measurement. Still, are you able to feel that PQ by AB doesn't necessarily mean that PQ and AB will be equal? It doesn't mean that these two are equal. Does it mean?
Um,
Okay, always it doesn't happens like this. This will only be true when PQ by AB is 1. Okay, so when you are saying that the ratios are same, that means the ratio can be anything. The ratio over here can be 1/2, 1/2, 1/2. Okay, it doesn't mean that PQ and AB will be same, QR and BC will be same, PR and AC will be same. From the ratio you are not able to give the conclusion that the sides will be exactly same with each other. And since we cannot give that conclusion, hence we cannot say that PQR and ABC will be congruent. So from here, we cannot say surely that PQR and ABC will be congruent. Are you getting it, everyone?
Yes, ma'am.
If
Yes,
congruent,
ma'am.
then similar. If congruent, then similar. But if similar, then not sure about congruency. Okay, now again here few criterias we are having. Similarity, you have, okay, let me take few examples from here, just a moment. Now there is a concept over here that if we are taking one equilateral triangle ABC, equilateral triangle ABC, and a equilateral triangle PQR. Okay, here the sides of ABC can be anything, maybe XXX or maybe 2, 2, 2. And PQR, their sides can be, okay, I'm just taking 1, 1, 1. Okay, if I have taken equilateral triangle ABC and an equilateral triangle PQR, are you having the feeling that this two will always be similar with each other?
Yes, ma'am.
Equilateral triangles are always similar with each other. Whatever be the measurement, you can see AB by PQ. Yes, it is same. Okay. AC by PR. Whatever way you will try creating the ratio, yes, it is same. Okay. BC by QR. Yes, it is same. And angles, of course, it is equilateral. Each and every angle over here will be 60, 60, 60. So we can compare whatever way we want. And we will find that, yes, one of the angle here, one of the angle there, one of another angle here, another angle there. Third angle here, third angle there. It is same, hence similar. So from here, I am going to declare that two equilateral triangle will always be similar. If I am mentioning two equilateral triangles are there, you are not going to ask me what is the measurement. You will say yes, similar. Because whatever is the measurement, it will be similar. Getting it?
Yes, ma'am.
Yes,
If
ma'am.
even if I will make it 8, still similar. If I will make it 108, still similar. Equilateral triangles are always similar. Why? Because all three sides here and all three sides there are equal with each other. And angles automatically due to equilateral 60, 60, 60. So it will always be similar with each other. Okay, this is statement you will be getting here and there in a certain reason based question and in fill in the blanks question that two equilateral triangle are always similar. You will say yes, it is true. Okay, now the next figure which will always be similar is when we are talking about similarity, we can discuss about any shape, any shape. Okay, I started with a quadrilateral. You can take any shape. So just let me show you another shape. Are you able to see this screen, this one note?
Yes, ma'am.
Okay, if I am taking a circle and I am taking another circle. Okay, now if we will if we are trying to compare these two circles are similar or not. We are just trying to compare these two circles are similar or not, because we can compare any shape. Similarity means this chapter is talking about similarity of triangle, but we can think about similarity for any shape. Okay, so suppose the first circle is having the radius 2 centimeter and the second circle is having the radius, let's say, 8 centimeter. Okay, now similarity means I told you all sides must be in proportion. In proportion means maintaining same ratio with each other. And corresponding angles must be equal with each other. This is the like just two condition we are having. This has to be fulfilled, then the figures are similar. Okay, so let's think about the first rule. Rule number 1. Okay, all sides must be in proportion. If you are thinking about circle, we don't have any side. So what is the dimension of the circle? What is the measurement? Radius. Radius gives the proper measurement of any circle, right? If you will try
Yes, ma'am.
checking radius 1 by radius 2, okay, you don't have any other radiuses to compare. Okay, in circle there is one and only one. Okay, whatever be the number of time you are drawing the radius, this is just same thing. Okay, same thing, so you don't have any other thing to compare with. ओके हमारे पास सर्कल में कुछ और है ही नहीं कंपेयर करने के लिए कि रेडियस 1 को रेडियस 2 से कंपेयर करें रेडियस ओके अनदर रेडियस अनदर वी विल बी कंपेयरिंग विद द अदर वन वी डोंट हैव एनी अदर थिंग टू कंपेयर इफ वी विल ट्राई क्रिएटिंग द रेशियो वी विल जस्ट बी गेटिंग द रेशियो r1 by r2. Okay, and what about angle? Angle will always be same. Circle means okay we are just moving one complete revolution 360 degree. So in both the cases we are moving one complete revolution 360 degree. Okay, so angle is maintained same. Proportion means side we are not able to check. Hence all circles of any measurement will always be similar with each other. Are you getting it? Any two circle are similar with each other. Any two circle. If I will draw any two circle, you will not ask me what is the measurement. You will say yes, this two will be similar. Getting it?
Yes, ma'am.
Any two equilateral triangles are similar with each other. Any two circles are similar with each other. And any two square are also similar with each other. Are you getting the feel? Getting it? Square means all sides will be same. So automatically your ratio will come out as the same. And each interior angle will be 90 degree. So your angle will also be same. Getting it? Yes or no?
Yes, ma'am.
Okay, just a moment. Let me take few examples.
Ma'am, can you explain how the two circles are similar again?
Okay, when we are talking about other figure, other shapes, okay, the condition for similarity is uh, all side all sides must be maintaining same ratio, right?
Yes, ma'am.
And all like corresponding angles has to be same. When I am talking about circle, okay, when we are discussing about circle, then we cannot see any other side, right? So many sides are not there. Circle's dimension means we only know the dimension of circle means we are talking about the radius of the circle, right?
Yes, ma'am.
So here suppose I am saying the radius is 5 and here I am saying the radius is 6. Now you will try checking whether the ratios are maintained properly or not. So you don't have any other ratio by with which you can compare. Are you getting? R1 by R2 will be 5.
Ma'am, but like if if one if one circle's radius is not divisible by another uh, radius, like another circle's radius, but it will not be like similar, right? Similar, right?
Divisibility, I'm not saying. I'm just saying that ratio will be same. Okay, for other shape, suppose let me take another shape. Suppose you are having a parallelogram and you are having another parallelogram. So here you are able to match the ratio. Suppose this one is 2. Okay, this one is, let's say, 5. Okay, this one is 3. Okay, this one is 15. Wait, this one is 4. This one is 6. Okay, this one is again 2. This one is 4. And this one is again 3. This one is 6. Okay, this is how the measurement are given. So here you are able to match the ratio. You can check the ratio between AB to CD. Again, I have taken a number which is divisible. Okay, it can be the number which is not divisible with each other. For example, you can have it 1 centimeter, you can have it 7 centimeter. Okay, if you are thinking that similarity means we are checking the divisibility, that is not the meaning of similarity. Okay, suppose this is how you are having the measurement, okay, for the parallelogram. One of the side length over there is 7 and the breadth is 35. And here length is 1, breadth is 5. Is it clear so far, the data?
Yes, ma'am.
Okay, so the first
Yes.
one, parallelogram ABCD. ABCD. And the next one is parallelogram PQRS. If you will try checking the ratio between AB to CD, or no, AB to PQ, one of the side here, one of the side there, you will get the ratio as a 1 by 7. It is divisible, not divisible, doesn't matter. Okay, we are trying to cancel it out. We are not able, we will leave the ratio as it is. The fraction we are leaving as it is. Now we are checking the other ratio, that means BC by QR. That is coming out as a 5 by 35. That means we will try cancelling them. 5 1 times 5, 7 times 35. Here also we are getting 1 by 7. If this one and this one is same, okay, you can understand the other two will also be same because we are talking about parallelogram, right?
Yes, ma'am.
Okay, you can understand that CD and RS will also come out as the same. Okay, and this AD to PS will also come out as the same. So if these ratios are maintained same, and each and every interior angle, corresponding angles are also same, okay, corresponding angles are also same, then you can say that these two figures are similar with each other. Is it making sense?
Yes, ma'am.
But when we are
Yes.
talking circle, we don't know how to compare. Do we know? Do we have so many sides? No. Okay, One of the circle, another circle. What to compare, we don't know. Only one data we are having here, that is the radius. Radius 1 and radius 2. Okay, how to compare the ratio R1 is to R2? With what we will compare? We don't know. Okay, so we conclude that yes, the figure is a stretch or compress with a certain proper, okay, proper maintaining the measurement. Getting it?
Yes, ma'am.
Okay, because we don't have any other thing to compare with. That's why we conclude that any two circle, I will draw on the screen any two circle, and the two circles are similar with each other. I'm not saying congruent, okay, because congruent means exactly same. My this palm and this palm are congruent with each other. You can see both are covering each other completely, okay. But two circle, any two random circle will not be congruent, but it will be similar, because similar means one shape can be smaller, another can be bigger. While making it bigger, we are just maintaining a proper ratio. Each and every side we are just stretching in a, okay, if one of the side I stretch double, another side also I will stretch double. That's how we are maintaining the side. And angles also we are keeping same, corresponding angle, the way corresponding angle in the congruency, here also corresponding angles are same. Okay, so about circle, if we are thinking about the angle, then any circle you draw, this complete angle will be 360. Any circle you draw, a teeny tiny circle or a huge circle, this angle will always be same. Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay, on the basis of this two data only, we are just declaring that any two circle are always similar with each other. Getting it?
So like pi does not matter here.
What doesn't matter?
Uh, Pi or like the perimeter does not matter here.
Yeah, okay, perimeter doesn't matter over here because we are not talking about the perimeter of any shape. Okay, in the previous shape also, if you have checked, I'm not talking about the area, perimeter, or the volume. I'm just checking the sides. Each and every sides are stretched or compressed in a proper ratio or not. You can see this radius, 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 all you will find that the ratios are same. Yes or no?
Yes, ma'am.
Okay, area and perimeter we are not checking. When we are talking about congruency, we are starting with the side and we are ending over here. Making sense?
Yes, ma'am.
Okay, now you can, if you that way it is not making sense, then you can also think this way, that so many radiuses are here and all are maintaining same ratio. If this is 2, this is also 2, this is also 2, this is also 2, this is also 2, this is just like that equilateral triangle. Okay, just like that square, and hence all are maintaining same ratio. How many such radiuses are there? Infinite. There also infinite, here also infinite. But one thing we are sure, that all these radius and all those radius will maintain same ratio, right?
Yes, ma'am.
Clear? Or still you are not convinced? If still you are not convinced, then in next class I'll try taking an example which will make more sense. Okay, but today I'm keeping this much. And yeah, we have just started with the introduction, so far we have not covered